Today's lesson is a review of 6.1 and 6.2. Let's go ahead and start with the first example, which is to simplify this rational expression. Remember, when we are simplifying a rational expression, we're going to go ahead and take the numerator and the denominator, and we're going to need to see if we can factor them. So let's go ahead and start with the numerator. I'm going to take the x squared term, and I'm just going to ask myself, what times what is x squared? Well, that's going to be x times x. Then I'm going to go to the c term, which is the last term of my polynomial, and I'm going to ask myself, what times what is 12? Now, there are multiple ways to multiply two numbers to get 12. The first that comes to mind to me is 2 times 6. Now, what I need to do is I need to make sure that 2 times 6 works. If I stop and take a little bit of time, I can figure out which one I need to use by looking at the b term in the middle. I need to ask myself, can I make 2 and 6 become 1? Now, don't worry about negative or positive right now. Just think of 2 and 6. The only thing you can do is add them or subtract them. So if I think about it as 2 plus 6, well, that's 8. And if I think about 6 minus 2, that's 4. Neither of these two numbers is negative 1. So 2 and 6 is not going to work. So I'm going to cross them out. So now I have to think of two other numbers that multiply to 12 but can sum to 1. You might be thinking 3 times 4. Let's go ahead and see if it works. 3 plus 4 is 7. 4 minus 3 is 1. There we go. We got 1. If we can get 1, we can get positive 1. If we can get 7, we can get negative 7. We just need to play around with the signs. So I got 1. I think it's going to be 3 and 4. You might be thinking, well, couldn't I say 4 times 3? It's the same thing. All right, let's go ahead and crisscross multiply. X times 3 is 3x. X times 4 is 4x. And just like we said, we're pretty sure we can make that be negative 1x. Now remember, when we talked about this on Friday, we said the bigger number gets the sign of the answer, and the other one in this case would be the opposite sign. So I'm going to have a positive 3 and a negative 4 right there, which means the top, my numerator, the top of my radical functions, now let me pull that back, is going to factor into x plus 3 and x minus 4. Now I'm going to go ahead and do the same for the denominator. X times x is, of course, x squared. And we're going to stop and we're going to do the same thing with positive 20. So I want two numbers that when I multiply them, I get 20, but I have to stop and think that when I add them together, I get 9. More specifically, negative 9. Now, the first thing that came to my mind was 2 times 10. I know that 2 and 10 are not going to work now that I stop and think about it, because 2 plus 10 is 12 and 10 minus 2 is 8. That's close, but not close enough. 8 and 9 are not equal. So I have to think of something else. Let's keep thinking. What could it be? Oh, I know. 5 times 4. 5 plus 4 is 9. If I can get positive 9, I can get negative 9. All right, here we go. 5 and 4. Let's go ahead and cross multiply. Remember, I'm cross multiplying the x to the number. That's because it needs to do that so that I get the proper sign in the proper place, and I get a leading coefficient correct in the correct spot. Like if I had a 2x here, then it would make a difference. This one would be 10x. And if I had a 2x here, this one would be 8x. And so I just need to be careful as to where I put it, which one would work. Okay, I want 9x, but I want negative 9x. Remember, we talked about the last time we had to make it the bigger of the two numbers takes the sign. So 5 gets the sign, right? But negative 5 plus 4 does not equal negative 9. Negative 5 plus 4 is equal to negative 1. But we know that 5 plus 4 is 9. My, all I have to do is make them both negative. Why does this work? Well, that's because 20 is actually positive. When 20 is positive, my answers can be both positive, which would mean my sum is positive, or in this case, when my sum is negative, both of these are negative as well. Both my factors are negative as well. So there we go. We've gone ahead and factored the denominator. Let's go ahead and place the factors into place. There we go. Okay, now remember you need to look at your numerator and your denominator and you need to say, what can I cancel? Remember, it has to be exactly the same top and bottom for us to be able to cancel. I think that's the only one. I'm just going to check to make sure that this number and that number do not match. This sign and that sign do not match. All right, we have an answer. We have x plus 3 on the top, and we have x minus 5 on the bottom. This is our rational expression answer. All right, the last one I wanted to show you today is an adding problem from 6.2. It does ask us to simplify our answer as much as possible. Now remember, for this lesson, you need to make sure, just check with your eyes, I'm using my highlighter to check, that both of my denominators are the same. If both of my denominators are the same, then I can go ahead and make one fraction by either adding or subtracting my numerators. Or sorry, my numerators. Now just remember, if this is minus, you need to make sure that you put a parenthesis here so that you distribute that negative to the second um, denominator, numerator. Numerator. All right, let's go ahead because we have plus, we have add. We're going to go ahead and just combine together our two numerators. Now remember, the denominator is your common one. I talked about it being like I'm having pizza with my family. Normally, a pizza comes in 8 slices. If I add my 2 slices plus my daughter's slice, there's 3 slices of pizza. I wouldn't be able to add her slice to my slice if she ate from a smaller pizza. Let's say she had a personal pizza and it was only cut into 4 pieces. Her piece does not match the size of my pieces and cannot be taken out of the whole pizza. I also wouldn't say that I had two-eighths of the pizza and she had an eighth of the pizza. So together we had 3/16 of the pizza. We're still only having 3/8 of the pizza because there's only 8 slices. I'm not going to slice it into more slices. All right, now when you have a polynomial like this in the numerator with more than one term, this one has 4 terms, it probably means that there's something that we can combine together. We can go ahead and combine the negative 5y plus the 7y. And we can go ahead and create them and say, well, that is y squared plus 2y minus 15 over y plus 5. Do I have to factor the top, the numerator? Let's see. We're checking to see if 15, it has 5 as a multiple. So what I'm thinking is 15. Can it be 5 times something? Yes, it can. 15 is 5 times 3. I'm going to have to go ahead and factor the numerator. So I'm going to take my 15. It is negative, so one of them is going to be negative. And then I need to think of y squared as being y times y. So I have to factor the top because I got that pesky 5. Let's go ahead and cross multiply. And I think that 5 and 3 can become 2. I think I can make them into 2 by simply saying this one is positive and that one is negative. So there we go. I've gone ahead and factored my top and into y plus 5, y minus 3. And I have the y plus 5 in the denominator. Now I can go ahead and I can cancel the y plus 5 because there's one in the top and one in the bottom. And that leaves my answer of y minus 3. Today, I'd like you to make sure that you finish either 6.1 or 6.2. 6.1 closes on the 16th, that's this Thursday, and 6.2 closes on Monday, the 20th, which, by the way, we don't have school that day. Please ask Mr. O'Neill for any help that you have, and I will see you guys on Thursday. Bye.